Have you ever wondered why black coffee tastes so bitter or why a piece of chocolate tastes so sweet? I truly enjoy food, but my mind has definitely been plagued with why some foods taste delicious while others are absolutely horrid.
Believe it or not, acids and bases play an enormous role in why food tastes the way it does. You might be asking yourself, what does it mean for something to be acidic or basic? Well, it all relies on ions. Ions are one or more atoms that bear one or more positive or negative electrical charges. According to Johannes Bronsted and Thomas Lowry, an acid is a substance that donates hydrogen ions, while a base is a substance that accepts these hydrogen ions. The acidity of a solution is measured by the pH scale. A pH of 7 is considered neutral, while anything below is considered an acid, and anything above is a basic or alkaline substance. A perfect demonstration of a natural pH indicator would be using a red cabbage. Red cabbage contains an abundance of pigments called anthocyanins. Through extracting these pigments, a natural pH indicator is formed. Now, anthocyanins are weak acids that can dissolve in water and are extremely susceptible to changes of pH. This allows for the magic to happen. Notice how each solution is clear to begin with, yet when the indicator is added, each turns a different color. Essentially, the more acidic the solution is, the more pink it will be, while the more basic a solution is, the more blue it will be. So we can easily conclude that vinegar is acidic, baking soda is basic, and the club soda is slightly acidic. Now, what does this have to do with food? Well, acids in food liberate the hydrogen ions, and the concentration of these ions determines the degree of sourness. The decomposition of food by bacteria produces acids or hydrogen ions. For instance, lactose, a type of disaccharide found only in milk and milk products, when combined with lactic acid bacteria and water is converted to lactic acid. Yet extreme sourness can be a warning sign of bacterial contamination of food. Not good. Hydrogen ions bind to acid-sensing channels in the membranes of taste cells. When these channels are activated, nerves are then signaled. Research shows that an acid-sensing cation channel is the main transducer of sour taste. It is believed that bitter taste may have evolved to protect us from poisons. Bases, most of which are usually toxic, elect a bitter taste. Chemical compounds such as quinine produce a bitter taste by binding taste bud receptors that couple to G proteins. This activation initiates a process called a signaling cascade, which is when cells communicate with the external environment, interpret stimuli, and respond to them through transmitting biochemical information between cell membrane and the nucleus. This cascade produces the sensation of bitterness. So the next time you enjoy a delicious meal, remember the science behind that wonderful taste.